Hello, Dr. Andrade's ASCE 100 class. My name is Shahab Mastori. I'm a civil engineering student here at the University of Maryland, studying transportation and project management. A little bit about myself. I worked as a transportation engineering intern for Dewberry Engineers over in Owings Mill, Maryland. During my time there, I conducted sidewalk feasibility studies during site visits in Indian Head, Maryland. We needed to assess if the sidewalk could be implemented alongside a two-lane highway. So measurements of distances for existing utilities to potential sidewalk implementation locations were taken persistently, consistently, and as accurately as possible for our final report. I was also doing things like roadway widening projects, which involved doing horizontal and vertical alignment in a software that civil engineers love to use called MicroStation. I did inspection field work for design of drainage structures, inspected drainage facilities, and while doing this, I always researched and complied with the AASHTO guidelines. And if you don't know what that is the American Association of State Highway and Transportation Officials. So overall, I was analyzing utility data for design conflicts all the time, and cost of designs were involved. So everything had to get done thoroughly, accurately, and with strong integrity. So why do ethics matter in the field of civil engineering? Well, that's because civil engineers shape society's infrastructure, and ethical decisions ensure safety and trust. The ASCE Code of Ethics sets a great standard for professional conduct. What's the real-world impact, you might ask? Well, any ethical lapses could lead to disasters like structural failures. So my goal here is to equip engineers to navigate these tough decisions with confidence. Moving into a real-world example, I'm going to be talking about the Surfside collapse over in Miami. So there was an original structure, which was a flat plate, two-way slab system, no beams, just a slab and columns. But this original structure was modified, and there was added weight through topping slabs and heavy planters, and this all added too much weight that was not part of the original design. The extra weight caused something called deflections, which was the slab and column movement, and punching shear, which was the column pushing through the slab. Cracks began to form, and the only thing holding the slab now was rebar. But this rebar had issues. It was misplaced during construction. It was inadequately at the slab and column joints, and the original design didn't properly address this punching shear. So when one column failed, the load shifted to all the others in what is called structural resiliency, causing the pool deck to collapse and damages to the joint connections. There was a lack of ductility, and we as engineers stand by the principle of bending but not breaking. So we try to make structures that can manage weight in a way that they'll bend but never break. This one happened to break. So there was only a partial collapse actually in this building, because there was actually a really cool design called a shear wall, which actually ended up saving half of the building. So the lesson here was that structures change over time, so inspection and maintenance are critical for structures like this. Overall, we need to begin to require more enhanced inspector training, certifications, and peer review of these structures. And this building actually collapsed due to a number of failures. So if any of these factors were less severe, then the building wouldn't have failed. But in this case, it's that thoroughness that's key. We need to be more thorough with these certifications, inspections, original design. And definitely do not add weight to structures that were not designed to be added weight to. Now, knowing how catastrophic and detrimental ethical lapses can be in this field, I want you to take a second to reflect and Think about what you would have done differently if you were the Surfside building engineer, or even the one inspecting the building to make sure that it was maintained over time. Would you have been more thorough in your work? Go ahead and do some reflection and think about what you would have done differently. Following up with that question, I want to know, have you encountered an ethical challenge in a project or internship of your own? And how did you address this? So now I'm going to be moving into the 5 fundamental canons provided by the American Society of Civil Engineers. The first being society, the second being the natural and built environment, third being profession, fourth being clients and employers, and fifth being peers. Moving into that first one, society. General guideline here is that engineers must prioritize the safety, health, and welfare of the public. Why does it matter, you ask? Well, it ensures engineers design and maintain infrastructure that protects lives and prevents tragedies through diligent oversight and accountability. I'll give you an example. An engineer designing a bridge notices a flaw in load calculations that could lead to collapse during heavy traffic. Despite a tight deadline, they report it to the project lead, leading to a redesign that ensures public safety. I want you to think about this scenario and what you would do if you found a safety flaw but were told it's minor. Would you go ahead and just try to make a push for the deadline, or would you actually think about it? Think about the impact that it could have if you just are careless and you go to your project lead and allow more time to be took to ensure safety of the design. The second canon is the natural and built environment. The general guideline here is that engineers must adhere to the principles of sustainable development. And why does it matter, you ask? Well, it protects the public's welfare, preserves resources, builds trust, and drives innovation. I'll give you an example. There's a really cool building in Seattle called the Bullitt Center. It's nicknamed a living building because it uses solar power, rainwater harvesting, and it produces net zero energy, meaning just as much energy that goes into it is what you get out of it. So I want you to look into this building just a bit. Look at all the cool stuff that is featured inside of it, and maybe think of one more sustainable feature you'd add to the building. Moving into that third canon, profession. The general guideline here is that engineers must uphold the honor, integrity, and dignity of the profession. I'll tell you why it matters. Because representing your qualifications truthfully builds trust with clients, colleagues, and the public. I'll give you an example. An engineer is tempted to exaggerate their experience to win a project bid, but chooses to be honest, stating their actual expertise. Being honest earns this engineer a collaborative role with a senior engineer, gaining the respect from the senior engineer and a better project outcome. Think about that scenario for a second, and then I want you to think about if you've ever faced pressure to overstate your skills. How did you handle it? Moving into the fourth canon, which is clients and employers. The general guideline here is that engineers must act as faithful agents of their clients and employers with integrity and professionalism. Why does it matter? Because acting with integrity builds trust, ensures project success, and upholds the profession's reputation. An example here is an engineer at a firm is offered a side consulting job by a client's competitor, but they decline the offer and disclose it to their employer to maintain trust. I want you to think about you being in this similar situation and ponder how you would handle a tempting side offer from a client's rival. Would you take it, or would you think about upholding ethics and maintaining good standards within your company? And last but not least, the fifth fundamental canon provided by the ASCE is peers. And the guideline here is that engineers must only take credit for professional work they have personally completed. Why does it matter? Because only taking credit for your own work ensures fairness, builds trust with peers, and upholds professional integrity. Give you an example. A young engineer on a team project is tempted to claim full credit for a successful design, but acknowledges their specific contribution. For example, maybe they did load analysis and they give credit to the teammates for their other parts. And I have a question for you. If a teammate were to take all of the credit for a project you worked on together, would you A, confront them personally, B, discuss it with your supervisor, or C, just let it go? It's no big deal. I know that many of you guys are just now starting your civil engineering journey, and that thinking about what you're going to be doing 5 years down the line might be a little bit overbearing, but I do want you to think about what ethical issues you anticipate in your career. And for any of these ethical issues that you can foresee, I want you to think about how you will apply any of the 5 canons of the code of ethics that I just provided to these scenarios. That way you can be more prepared down the line when these challenges come up, and you can attack them and get through them with confidence. And last but not least, I'd like to share what ethics in this field of civil engineering means to me. To me, being ethical means doing the right thing even when no one is watching. So let's say your boss is on vacation. What are you doing then to make sure you're upholding the standards of ethical engineering? Are you staying on top of all of your work, doing it diligently? Are you still checking back in with your team to make sure that you're doing things the right way? Peer collaboration still going on. It means being safe, responsible, and respectful at all times. It means not taking someone else's work and calling it your own. We've learned that for however many years we've been in school now, that plagiarism is not okay, and that even if you do use another source, it's always good to cite that source. And honestly, it means putting the time in to be well-researched and knowledgeable about the subject and the field of engineering in general. We spend a lot of time in school to learn, so it's important that you stay sharp and keep those engineering skills in mind whenever you are working on a new project. And lastly, it means building good relations with clients by always being truthful and thorough in your work. And that one's pretty self-explanatory. I mean, it's always good to be as diligent as you can. It's always good to be upfront if you can't get something done on time. It's never good to lie to your clients because you want to maintain a good relationship and build trust with these clients, because this trust is actually how you are going to make money for the company. Without clients, your company will fail because there's no money coming in. And that wraps up my presentation to you guys about how important ethics is in the field of civil engineering. What I want you to take away from this presentation is that your commitment to ethics shapes the future of civil engineering. And if you'd like to review the ASCE Code of Ethics further, I will provide a link for you guys on the assignment. And you can always reach out to me with questions. My email is shahabmastori@gmail.com. And I'd like to thank you for committing to ethical engineering.